Hello and welcome to the Section 9.1 lecture today for Algebra 1 Part 2. Today we're going to start our work with systems of equations. So it's a big kind of turning point in math where, we start to get to a little bit more abstract thinking and the difficulty definitely increases also. Anyways, let's go ahead and get started. A system of linear equations is we're just going to say a set of two or more equations that that occur at the same time. Okay, so any system of equations or system of linear equations, or sometimes even the long, name of it would be a simultaneous set of, or a simultaneous system of linear equations. Anyways, when we talk about the solution to that, it's always just going to be the point. How do I want to say it in the tough way? I'm not going to say it the tough way. I'm going to say it the easy way. The point where the two lines cross. Okay, now why is this a solution? Why is this the thing that we're looking for? Well, we're looking at a common value or a common set of values between two equations, and that's going to come out to be a single point, and it's going to be the point that those two lines have in common. So we're looking for the point where those two lines cross. Let's go ahead and try this first one. Now these ones are both in standard form, so I'm going to think about the cover-up method. For the first one, I have 2y equals 4, which tells me that y is 2. Y-intercept is 2. And on the second one, that one's not too ugly. 3x equals, or not too ugly, not too good looking, because that means that the x-intercept is 4/3, so about 1 1/3, somewhere in there. Now the next one, when I cover up the x term, I get 3y equals negative 5. So y is equal to negative 5/3. And so, let me actually switch colors too, because that's my y is equal to negative 5/3. So that's going to be somewhere in there. And when I cover up the y term, I get negative x equals negative 5, which means the x-intercept is 5. All right, now here's the issue with this method. I don't really know, and sometimes I can be pretty dang exact, but other times, there's some differences in what I've got going on here. Like, I don't know if I graph like a y-intercept or an x-intercept of like 1 1/3 or 1 2/3. I don't know if I do that really well. So I see what I think could be an answer on this one, but I'm not positive. So, I think it could be right here. I think it could be at 2, 1. But again, I'm not super positive. So that's why we talk about this method of doing it as a graph and check. If you get something that kind of feels off of a point just a little bit, we are looking where the two lines cross, and they do cross right there. But I don't know if this one's graphed right. I don't know if this one's really graphed right. So I'm going to use the point that I think it is, okay, thinking that it's 2, 1. Sorry, 2, negative 1. I think that it's 2, negative 1. I'm going to try that in both of my equations. So as I plug in 2, negative 1, In the first one, I get 3 times 2 is 6, and 2 times negative 1 is negative 2. So I get 6 minus 2, which does equal 4. And in the second equation, I have negative 2 plus 3 times negative 1. Now that's going to be negative 2 minus 3, which does equal negative 5. So there I've checked that point in my two equations, and it seems like it works out just fine. So I would say the answer to this is 2, negative 1. Now, if you graph ones and they're just completely obvious, then go with it. Okay, don't waste a whole bunch of time checking, and I wouldn't even write all that stuff out anyways. I would just try to do it a little bit quicker. All right, this one here, I've got a y-intercept at 3 and an x-intercept at negative 6, which is going to be about here. And we'll take that just as kind of a guess for now. And the other one I've got even better. I don't know how I'm supposed to graph this one. With an x-intercept at 24 and a y-intercept at 6. We can kind of do the y-intercept, but thinking that we're going to get to the x-intercept is ridiculous. So I'm actually going to turn this one into slope-intercept form. It's not really going to matter, but we would subtract x on both sides. So 4y equals negative x plus 24. And when I divide by 4, I get 1 over 4, negative 1 over 4x plus 6. So I do know that it's going to come down 1 and go over 1, 2, 3, 4. So I do know that it's going to go through this point. Other than that, that's about the only thing I can see on that line on this graph. And that it's going to go through that one. So if this answer was anything that was on our graph, it's going to be 4, 5. Right? It's going to be this point right here. So let's see if it is. I'm thinking it's 4, 5. So negative 4 plus 2 times 5. I believe that equals 6 because that's negative 4 plus 10. So that equals 6. And then 4 plus 4 times 5. Well, 4 times 5 is, oh, wait a minute. That's, no, that's right. I was thinking that was negative, but it's not. That's going to be 4 plus 20, which is 24. So it turns out that our answer, and again, whenever I'm answering these, I'm saying what the point is. I'm saying the point is 4, 5. It's where those two lines cross. So that's important. Let's hope this one works out a little better. It looks like I've got a y-intercept of 2, x-intercept of negative 1, y-intercept of 6, so kind of better, kind of not, and an x-intercept of negative 1.5, 6 over 4, yeah. So that was positive 6 as the, well, let me get this first line drawn, because I feel good about that one. Coordinates work out really well. But on the other one, we didn't get so lucky. Darn it. That's okay. So then, yeah, we had a y-intercept of 6 and an x-intercept of negative 1.5. So I feel like I missed a little bit on both those lines. I want to try to fix this one first. I think it's right there. I think that one's right there. It looks like my answer is going to be negative 2, negative 2. If I had to guess, that's probably what it's going to be. But let's check it. And if we have to adjust it a little bit, then we do. 2 times negative 2 minus negative 2. 2 times negative 2 is negative 4. And then minus -2 is +2. -4 plus 2 is -2. So that one works. Let's check in the other one. 4 times -2 minus -2. 4 times -2 is -8. -8 minus -2, or -8 plus 2, is -6. So that works also. So our answer is -2, -2. So you see how sometimes it's really important that we check it because we don't have the best information. Well, this is kind of easy and kind of hard. If you want to try to graph them, try to remember how to do that. I'll give you a hint though. This actually tells me what my x-coordinate and my y-coordinate is when these two lines cross. I have a line through the, wow, let's stop even trying that. My x equals 4 line is here. My y equals -3 line is here. Those two lines definitely cross at 4, -3. I'm not checking it. I believe it. Let's see, the next one is a little bit nicer too because it's written in slope-intercept form. So for the first one, we have a line that goes through 2, down 2 and over 1. And this will be a time that I'm actually going to step out my slope instead of drawing my line right away. And let's see if I can get my answer without even needing to draw a line. My other one goes through -3. It has a slope of down 1 over 3, but I'm not going to get there. So let's go up 3 and back 1. 1, 2, 3 here. Oh, wow. Nice try. Hey, eraser. Work for me. It goes through -3. And instead of a slope of -3, let's do a slope of -1 over 3. And it looks like those two lines have that point in common. So notice I didn't even graph my lines yet, but I can tell you that the answer is going to be 3, -4. And that's, trust me, I don't know what I'm doing. I don't know what my hand's doing. Somehow I wanted to write -4 and I came up with 7. So, but 3, -4 is what we get there. I can always graph my line afterwards, even though that's terrible on hitting the points. There we go. And this one goes through here. So I've always found that when I'm graphing, so that I don't muddy it up and so that I don't worry about, oh, I need a perfectly straight line, I can just step out my slope a ways, and if my answers end up lining up, then I'm good to go. Let's go and pause the video and you try a couple. Hopefully you had a chance to do that. Let's get right into these ones. So this one's in standard form again. I'm going to go ahead and cover up the y term and get x equals 2. And I'll get y equals -3. So those are my intercepts for that one. Since I have standard form, it's probably going to be better if I just go ahead and graph my line now. It's a little bit harder to step out slope in standard form. So sometimes it's better if I just graph my line. And for the other one, if I cover up the y, I get x equals -2. And if I cover up the x, I get y equals +1. So we get those 2 points right there. And our lines are definitely going to intersect right over here. And it looks like, and I feel pretty confident with their intersection being at 4, 3. So 4, 3. Probably wouldn't hurt for you to check it. To check whether or not that's actually the answer. because you're the ones graded on it. So I'd think about that. This one is pretty cut and dry. Nothing like the last one where we got to step them out and they actually landed on each other. Let's see if that'll happen here. So this one goes through +3 and has a slope of -1/2. So I can get a couple of those out there. And then the other line starts at -2 and has a slope of up 2/1. And I should see something pretty cool just from that. That those two lines definitely cross at 2, 2. I can answer now. Right? There's no doubt that that's the answer. I put the same point on the graph twice. That's why there's no doubt. Right? If you run into that scenario, take the answer. Take it. Use it. Okay? Anyways, that being said, make sure you put any questions you have over on the left. Make sure you put those questions into the assignment for this video. Otherwise, I hope you have a great day, and we will see you in class.